Water. It's the lifeblood of industry. It cools our power plants, heats our hospitals, and it is essential for manufacturing everything from microchips to medicine. But here's the paradox. The very substance that allows these massive systems to run is also trying to destroy them every single second of the day. If you take raw water and pump it through a high-pressure boiler without changing its chemistry, you are essentially building a bomb. We're talking about catastrophic failures, pipes plugged with rock-hard stone in weeks. Today, we aren't just looking at plumbing, we are looking at the molecular warfare happening inside the pipes. Welcome to the deep end. This is unpacking the chemistry. To understand the treatment, we first have to understand the threat. This looks like clean water, but chemically, it's a soup of dissolved minerals, gases, and organic life. Water is the universal solvent. As it moves through the earth, it dissolves everything it touches. Calcium and magnesium, the hardness ions, these are the bricklayers of scale. Silica, sand essentially. If this deposits, it forms a glass-like coating. Dissolved gases, oxygen and carbon dioxide, these are your corroders. Now, imagine this water entering a boiler. Inside, we apply massive heat. Two things happen immediately. First, the water evaporates into steam, leaving the minerals behind. This concentrates the minerals, raising the cycles of concentration. Second, the heat changes the solubility rules. Most solids dissolve better in hot water, but some calcium salts possess inverse solubility. As the water gets hotter, they hold on less. So you have higher concentration plus lower solubility, the result, precipitation. This is scale. It looks like stone because it is stone. The most common villain here is calcium carbonate. Let's look at the reaction. It starts with calcium bicarbonate. When you apply heat, it breaks down into solid calcium carbonate. That solid precipitates onto the hottest surfaces. This is a disaster. It restricts flow and insulates the pipe, causing overheating. So how do we fight geology with chemistry? We can't remove every ion. Instead, we use threshold inhibitors and crystal modifiers. Imagine a crystal growing. We introduce polymers, long snake-like molecules. They absorb onto the crystal face and disrupt the lattice. Instead of forming hard brick, it becomes a soft sludge that doesn't stick and can be flushed out. We also use chelants like Edita. Think of it like a microscopic crab claw. It grabs the calcium ion and locks it inside a ring structure. Scale blocks the system. Corrosion eats the system. It is nature trying to turn refined steel back into iron ore. For corrosion to occur, you need four things: the corrosion cell, anode, cathode, electrolyte, and a metal path. At the anode, iron gives up electrons and enters the water. At the cathode, oxygen accepts those electrons. These ions form rust. But the real danger is oxygen pitting. This concentrates corrosion on a tiny pinhole, drilling straight through steel. In high-pressure boilers, we remove oxygen mechanically, but we need chemistry to finish the job. We use oxygen scavengers like sodium sulfite. It reacts with the dissolved oxygen to form a harmless sulfate. For higher pressures, we might use hydrazine. We also play defense with passivation inhibitors. These form a microscopic shield, breaking the electrical circuit between the water and the steel. We've talked about rocks and rust, now we talk about life. Cooling towers are the perfect breeding ground for algae and bacteria. The danger is biofilms. Bacteria secrete a sticky slime that is a better insulator than scale. A thin layer reduces efficiency by 20%. Some bacteria eat iron, others excrete acid and Legionella that can literally spray disease over the neighborhood. So, we wage chemical warfare. We use biocides. We categorize them into two types: oxidizers and non-oxidizers. Oxidizers like chlorine kill everything on contact. They burn through the cell walls of the bacteria. Non-oxidizers are the snipers. If bacteria build a shell, these poison their metabolic pathways. We alternate them to prevent immunity.